Hi guys, day 2 notes in our unit 0, which hopefully by now you realize it's unit 0 because we kind of had an extra unit and didn't want to have to renumber everything. So we backtrack. But we are looking at doing a little bit more factoring, and then there's a little more towards the end. So the first thing I want to do is actually give you a chance to just try a few on your own, which means write them down and then pause the video. Take a second and try them. All right. So I will always label the notes with what unit and day we're in so that you can hopefully keep things together. You should have been given on the first day that we were all together the packet of kind of notes and homework for this particular unit. But there's a lot of handwritten notes in this unit. That won't always be the case, but I know from geometry, you guys are really used to having worksheets for everything, and we kind of changed that up a little bit in Algebra 2. All right, first one, 2x squared minus 4x minus 96. Second one, 49x squared minus y squared. Third one, yep, there's a third one, squeeze it in, x squared plus 4. I genuinely want you to try each of these on your own. So get them written down. Take a moment just to pause the video. I'm going to keep rolling, but you pause, try them, and then turn it back on. Okay. So really quickly, going through it, the first one, you should be able to take out a GCF first. So take out 2, and then you have x squared minus 2x, and then half of 96 is 48. Then it's trinomial factoring, all right? And so I can then split this to be x, and then minus 8 plus 6. So hopefully your answer matches. Second one, we've got difference of squares. And people will say it differently. You might just say perfect squares. I've seen dots before for difference of 2 squares, I think, is what the dots was. Something along those lines. All right, this one we should have 7x plus y, 7x minus y. As for the last one, I hope that you realize this is not a type of factoring that we know. When it's a plus sign in between 2 perfect squares, it's not factorable. At least not with real numbers. We won't get into anything further than that for now. So if you did do x plus 2, x minus 2, that's all right. Cross it out or erase it and write yourself the note that because of that plus sign right there, it's not factorable. All right. So the types of factoring that we talked about in the notes from the other day were greatest common factor, so GCF. This will work with any number of terms. Trinomial factoring, which kind of tells you right there, it has to be 3 terms. So typically like an x squared plus 2x plus 1. And then the third type, the difference of perfect squares. And sometimes I just draw a square, however you want to state it, right? And in that case, it has to have specifically 2 terms. So here it could have anywhere from 2 beyond. Here's exactly 3, here's exactly 2. Right. What we want to focus on is using these, but in combination. So sort of like that number 1 up there from your little warm-up. So, excuse me. The directions are simply going to be to factor completely. So again, I'll give a little pause so that you have a moment to be able to pause the video if need be. And this way you can try some of these on your own, and then we will talk more about them the next time I see you in class. All right. So example number 1, you got x squared plus 7x plus 12. Oops. And I'm going to leave a little space here. Example 2, negative 32 y cubed minus 24 y squared. And then example 3, I think I can fit in here. I'm going to give you negative 36 y to the fourth plus 900 y squared. All right. Take a moment, pause, give them a try. All right, hopefully you've had a moment to try them. I'm going to write the answers next to them. The first one, x plus 3 times x plus 4, so that's trinomial factoring. The second one, there's technically two different ways you could do it, but it's a GCF either way. You could choose to take the negative out with it or not. It's not wrong if you leave the negative in. But I would probably suggest if there's a negative, factor it out. So we can factor an 8 out of each of those parts and the y squared out of both. So that's going to leave us with a positive 4y and then plus 3. If you tried it and you didn't take the negative out, then all it would look like is 8y squared, and then you'd have negative 4y minus 3. So technically that is an equivalent answer, but I would say that this one is probably where I'd go with it. That's the preference, to take that negative out. Hopefully, if you did that with the last one, it made your life a little easier here. So you might have had to grab your calculator and figure out what, 36 and 900. 36 actually goes in perfectly, and negative 36 even. So if I factor out negative 36 between the y's, I can take the y squared out. That'll leave me with y squared, and then it's going to flip this sign to make it minus 25. And here's where we really get to keep going. So this is now difference of squares. And so then y plus 5, y minus 5. And there we go. All right. So there's your first guy. So I hope that you were 3 for 3, but if you weren't, that's okay. All right. What I do want to talk about, since we've done a little bit of practice, is now one other method that can be helpful when we're trying to factor. And that's actually called using a dummy variable. All right. So I'm going to slide my paper down here. Whoops, a little squeaky there, so that we can still see what's happening. All right. So a method to help in factoring is called using a dummy variable. And when we say dummy, we're not saying like in a mean way, like you're a dummy. We're talking about like a crash test dummy, like it stands in place of something else. All right. So what a dummy variable will do here is it's a single variable that stands in place of an expression. And usually that expression is in parentheses. Right? That's usually kind of our clue to say like, hey, I might want to try using a dummy variable. So with this next example, let me show you what I'm talking about. All right, write this down. We have 2x, and then in parentheses, x plus 1, and then minus 3, and then in parentheses, x plus 1. And I want you to keep in mind what the goal is, because sometimes when we see parentheses like this, we think, oh, let's distribute it. It's not necessarily the worst idea, but if I distribute it, I'm doing the exact opposite of factoring. I would be expanding it instead of breaking it down into multiplied form. So when I see x plus 1 and then x plus 1 repeated, that's where I want you to think, let's try a dummy variable. So we're going to pick a variable that's not x. So you could pick anything. Sometimes we'll just pick a, you could pick y. There's no right or wrong answer except for using x again, because that's confusing. All right. So I'm going to use a. I'm going to use a capital A. I'm going to say, let's let A stand for when we see x plus 1. And now my first step is let's rewrite it using the dummy variable. So when I rewrite it, it's going to be 2x, and then in place of x plus 1, I'm going to put an a here. And then minus 3, and again, in place of the x plus 1, I'm going to put a. Now it looks slightly weird the way that I wrote it, right? So if it looks weird with the little dots in between, you could rewrite it underneath just to say, okay, it's 2xa minus 3a, all right? You don't have to rewrite it again. But now when you look at it, the idea is that maybe it's a little easier to see what kind of factoring it is. So if I ignore all this stuff above and say, okay, I've got 2xa minus 3a, I want you to factor that. Well, first thing we should always be looking for, GCF. They both have a, so I can factor the a out. Mm-hmm. So my next step is to factor, and in this case, like we said, the a is a GCF. Yay. So factor the a out, and then I'm left with 2x minus 3. There you go. Now you factored it. The only thing you have to do is you can't make stuff up in the middle of a problem. We hopefully know that by now. So since we made up the a standing for x plus 1, we just kind of have to undo that step. So we're going to sub back in for the dummy, right? So in place of the a, now let's put back in what a stood for. So a stood for x plus 1, and then keep the 2x minus 3. That is our answer in factored form right there. Mm-hmm. And now the first time through, you might be like, I'm not totally certain I get it. Have faith, try another one, see how you feel with it. So let me switch my page here. I'm going to come all the way back to the top. Adjust my spacing a little bit. Oops, and I'm a touch crooked. There we go. All right, so let's try another one. So this would be number 5. All right, so I'm going to give you parentheses 3x plus 2 squared plus 5 times 3x plus 2 minus 6. Mm-hmm. So when you look at this, I don't want to multiply stuff out. That's doing the opposite of what my goal is, because the directions are still to factor. But I see the same expression in both the parentheses. That's what I want to let the dummy variable represent. So you could change the variable if you're like, I didn't like that a from last time. Make it y, make it b, make it whatever you want, all right? So maybe I use y this time. I'll say, let's let y stand for that expression, 3x plus 2, all right? So first step, and now in our notes, I'm going to use the step of saying rewrite. By the time we go to do the homework, the practice, you don't have to show that part of it. Right? But in place of this, I'm going to put y in, and then I'm going to square it. Right here, plus 5 in place of it here. Put the y in, and then bring down the minus 6. Now that you have those crazy expressions in the parentheses gone, this is actually really easy to read. You have y squared plus 5y minus 6. That's just trinomial factoring. So let's actually factor it. So I know it's going to go y and y. Be careful with this one. Sometimes the 6 and 5 can be confusing. The fact that it's a minus 6 means one of the signs has to be plus, one has to be minus to multiply to get that negative. So if I want it to add up to 5, I got to go plus 6 minus 1. Right? If the signs were different, maybe you could get away with the 2 and the 3. Right? So now we've done the factoring step. Last step. Sub back in, all right? So if we sub back in the 3x plus 2, in the first parenthesis is going to go 3x plus 2, and then plus 6, and then over here, 3x plus 2 minus 1. Now, when you have parentheses inside parentheses, it can look a little clunky. Those are called nested parentheses. But if they're not needed, like in this case, it's not doing anything for me, I can actually drop these little parentheses. This is where if I used pencil, it'd be helpful, but I don't. So if I get rid of them, now I have 3x plus 2 plus 6, which is really 3x plus 8. And then same thing over here. 3x plus 2 minus 1 is really 3x plus 1. And there you go. All right. So after you sub back in, if you need to, just clean it up a little bit. And there is our answer. There we go. I'm going to leave you with one last one here, and then I think we'll save, I got kind of a crazy one. We'll save that for maybe in class. when I see you guys next. So last one here, we got 25 minus a plus b squared. All right, same directions. You're trying to factor it. So again, I don't want to multiply this thing out. That would be work that's not needed. Even though there's only one expression in parentheses, the fact that we see something in parentheses, immediately let that be code for I'm going to use a dummy variable. So since a and b are taken over here, maybe we let just plain old x represent that quantity a plus b. So I always want it to be that expression in the parentheses. All right, rewrite it. When we rewrite it, it's now 25 minus x squared, because you're subbing in for that right there. Right? When you go to factor this one, I got two terms. They're both perfect squares. Easy, except for it's still possible to make a mistake. The reason I say that, if it starts with the number here and then follows with the variable, make sure in your parentheses, square root of 25, the 5 and the 5 goes up front. Square root of x squared, x and the x goes in the back. 1 plus, 1 minus. Last part, sub back in. So you have 5 plus, and now we're putting back in for the x, the a plus b. And then we've got 5 minus a plus b. Now you technically could leave it like this. Again, it's a little clunky, but the final answer might be a little clunky regardless, right? So if you want to lose the parentheses, then it would be 5 plus a plus b. In the second parenthesis, though, you would have to actually distribute that negative. So it'd be 5 minus a and then minus b. Ooh, a little tricky. All right, but that's it. So hopefully that's enough examples using those dummy variables that you're feeling okay, and then we will talk more when I see you in class. Otherwise, until then, remember, be kind.